Welcome to another video. In this lesson, we're going to be focusing on changing the subject of the formula. We will be using the function machine and working backwards using the inverse operation to make the variable the subject. Let's have a look at a few guided questions that we're going to be beginning with. What is the inverse of addition? This would be subtraction. And these work inversely to each other. So therefore, addition is the inverse of subtraction. What is the inverse of division? This would be multiplication. Therefore, division would be the inverse of multiplication. What is the inverse of squaring a quantity? That's raising the quantity to a power of 2. This would be to take the square root. Therefore, squaring would be the inverse of taking the square root. And finally here, what is the inverse of cubing? And this is when we raise a quantity to the power of 3. Therefore, we would take the cube root, which is written like this. And therefore, cubing would be the inverse of taking the cube root. So we're now going to be looking at a few questions where we're making the variable the subject of the formula. So question 1. Make A the subject of the formula. So in this case, the first thing that we're going to be doing is we're going to be using the function machine to write down what is happening with the variable A that we're trying to make the subject. So this is where A is, and we can see here that if we start off with A, then A is being multiplied by 7. The second thing that's happening to A is we are adding 8B. So we're adding 8B. And finally, we have an output of 6C. Therefore, we're going to now work backwards using inverse operation from 6C, going all the way back to A. So let's start with 6C. Then we're going to be doing the inverse of adding 8B, which is to take away 8B. And then the inverse of multiplying by 7 would be to divide everything here by 7. And this would give us the value of A. And now that A is by itself, we would have made A the subject. Let's see if we can apply the same principle to question number 2. So we're being asked to make Y the subject. Therefore, the first thing we're going to be doing is to create a function machine starting with Y. And we're looking to see what is happening to Y. So this is a fraction to begin with on the right hand side, but the numerator of the fraction is the first thing that's happening to Y. So we can see here that Y, we're going to be adding 2Z to Y. So we're adding 2Z to Y. Secondly, we have this bar, this fraction bar, and that means division is now taking place. So here we are dividing by 3. And lastly, we have an output of 9x. So this is equal to 9x. So therefore, we're now going to be working backwards using the inverse operation from 9x to get to Y. So let's start with 9x. And then we're going to be doing the inverse of dividing by 3 which is to multiply by 3, and then we do this calculation here. So 9x multiplied by 3, 9 times 3 would be 27, and 27 multiplied by x would be 27x. So now that we're at 27x, we're now going to be doing the inverse of adding 2z. So the inverse of adding 2z would be to take away 2z. And this would have given us the value of y. At this point, you can pause the video and have a go at the next set of questions that you see here on your screen. And then we will look at the solutions shortly. Okay, welcome back if you had a go. So again, we've been asked to make x the subject in this case. So we're going to start with the function machine. So we're starting with x, and we're writing down exactly what's taking place with x. So at this point, we are multiplying by m. And secondly, we can see here that we are adding c, and then this gives us an output of y. So now we're going to be working backwards from y to get all the way back to x. So let's start with y, and then we're now doing the inverse of adding c, which is to take away c, and then the inverse of multiplying by m would be to divide everything here by m. And this would give us the value of x. Therefore, we would have now made x the subject. So well done if you got that question correct. Question number 4, you can have a go at this question as well. So you can pause the video and then return to see the solutions shortly. So let's have a look. It says make u the subject of the formula. So again, the first thing we're going to do is have a look and see exactly what's taking place with u. So we are going to start with u, and we can see here that this is where u is at, and u is being squared. So I'll just write the word square. Then we can see that we are then adding all of 2as. We're adding 2as. And this is going to give us a result for the output. So the output would be equal to v squared. So therefore, we're going to be working backwards from v squared to get all the way back to u. So now we have v squared. We're going to be doing the inverse of adding 2as, which is to take away 2as. And then we're doing the inverse of squaring. Inverse of squaring is to take the square root. So we're going to be taking the square root of everything there, making sure that we cover everything that we have there under the square root. And this would give us the value of u. So now we would have made u the subject. So well done if you got this answer for your working out. Let's have a look at another question. You may pause the video and have a go, and then come back to see the solutions. Again, welcome back if you had a go. So here we're making m the subject. So the first thing that I see happening to m, let's write that down, is we are underneath the square root. So this is what is happening at the moment. So m, we're adding h. Then we see the square root taking place. So now we're going to be adding the square root, and then this gives us the output of y. Therefore, I'm now going to be starting with y and working backwards, doing the inverse. So let's start with y, and I'm doing the inverse of squaring, which is to take of the square root, which is going to be to square. Then we're going to be doing the inverse of adding h, which is going to be taking away h, and this would have given us the result of m. So therefore m would be equal to y squared take away h. So we would have made m the subject. Question number 6, again, for this one, because we have this fraction that is multiplying everything on the right hand side, I want to rewrite this to multiply any quantity by 1/3. It's the same thing as dividing the quantity by 3. So the first thing that I'll do, I'll rewrite it in another form that would make things a little bit easier for me to work with. So pi r squared h is going to be divided by 3. This is making it appear a lot simpler for me to be working with, because I can now see what is really taking place with r. So we're trying to make r the subject. And we can see again, this is where r is, okay? So r is being squared at the moment. Then pi is just a number, and a number beside the letter h. That means multiplication is taking place. Therefore, we're going to be multiplying by pi h. Then we're going to be dividing by 3. And that would now give us the value or the output of v. So now we're going to be working backwards from this. So we're going to be working backwards from v. So let's start with v, and then we're working backwards by doing the inverse of dividing by 3, which is to multiply by 3. So that becomes 3v. V times 3 becomes 3v. And then the inverse of multiplying by pi h would be to divide by pi h. And then the inverse of squaring would be to take the square root. So now we're going to be taking the square root of everything here. And this is now going to give us the value of r. So this would be equal to r. So I'm going to give us a few questions to try on our own. So please pause the video and have a go at these questions. Okay, welcome back if you had a go. These would have been our solutions. So well done if you got those. With changing the subject of the formula, it could also be applied to questions relating to straight line equations. So in this case, we have the equation of line P is given by 2y take away 3x is equal to 14. And I have a guide to show that y is equal to mx plus c, which would be the general equation of a straight line. And m would be the gradient. So when y is by itself, we can actually figure out what the gradient and the y-intercept would have been. So let's have a look at this a little bit closer. So we want y to be by itself. We want to get it in the form of y equals to mx plus c, so that we can generate the gradient and the y-intercept. So one of the first things that we're going to be doing here is that we're going to be dividing everything by 2. So if I divided everything by 2, then we will have the following. We will now have y take away 3 upon 2, the number that is beside the x, I'll keep it as a fraction, and then this would be equal to 7. Now, we want to make sure that we have y being by itself. But y is not by itself at the moment, therefore we're going to have to figure out what is happening here with y. So we can see that if we write it as a function machine, then y, we're taking away 3 upon 2x from y, and then we have the output of 7. So therefore, we're going to have to now do the opposite, which is going to be 7, starting with 7. So we're going to be starting with 7 there, and then we're going to be adding 3 upon 2x. So we're going to be adding 3 upon 2x, and this would give us the value of y. So this is now going to give us the value of y, would be equal to y. So when we have a look and see what the gradient actually is, so the gradient is that number that is multiplying, the gradient is the number that is multiplying the x, okay? So we can see that it's going to be 3 over 2. So this is now going to be 3 over 2 for the gradient. 3 over 2 for the gradient. And the coordinates of the y-intercept will always begin with 0 and then the number that is hanging out there, which would have been the 7. So this would have been 0 and 7 would have been the coordinates for the y-intercept. Let's have a look at the next question. Again, for equation t, we have this equation, and again, the first thing we want to do, we want to get y by itself. So we want that number that is multiplying the y to just be 1, okay? And then we're going to be writing it as a function machine. So let's have a look. So we're just going to be dividing through by 5, and divide by 5, and divide by 5. So we can see here 20 divided by 5 would be 4, would be equal to the number that is now multiplying the x. We keep it as a fraction, or we reduce it where necessary. So this is still 4 over 5 x, and then plus y. So we want to get y by itself. So we need to figure out what is happening with y right there. So because we can see that in this case, if we write it as a function machine, we are adding 4 over 5x to get a new output there of 4. Therefore, if we begin with 4 and we work backwards, we can see that we're going to get 4, and then we're going to be taking away 4 upon 5x to give us the value of y. So from this, we can see that the number that is multiplying the x is going to be the gradient, and the number that is multiplying the x at the moment would be minus 4 upon 5. So therefore, this is going to be minus 4 upon 5. That's going to be the gradient of this line. And the y-intercept is going to be 0, and the other number that is hanging out by itself there, which is going to be the 4. And that would have been the coordinates of the y-intercept. So I would like for you to have a go at these questions. Please pause the video and have a go, and return to see the answers to these questions. Okay, welcome back. If you had a go, these would have been your solutions. And for the second set of questions, pause the video and have a go, and then return to see the solutions. Okay, welcome back. If you had a go, these would have been your solutions. I hope that you have learned so much from watching this video. Please continue to like, comment, subscribe, and share to the channel so that you can continue getting new uploads every time that we make content for you. I wish you all the very best, and I will see you in the next one.